The paper titled, IRIS, Interactive Research Ideation System for Accelerating Scientific Discovery, is authored by Aniket Garikaparthi, Manasi Patwardhan, Lovekesh Vig from TCS Research, and Arvind Kohan from Yale University. It explores how large language models, or LLMs, can speed up the early stages of scientific research, particularly in generating new hypotheses. At its core, the paper introduces IRIS, an open-source platform designed to help researchers brainstorm and refine ideas using LLMs in a more interactive and controlled way. The key question the authors address is how to make LLMs not just automate tasks, but truly collaborate with humans to avoid common pitfalls like generating irrelevant or fabricated information. The abstract highlights that while LLMs are advancing rapidly, previous methods for hypothesis generation often rely on multi-agent systems or extended computing power without enough human involvement. IRIS fixes this by incorporating a human-in-the-loop approach, meaning researchers can guide the process. It uses innovative features like adaptive test-time compute expansion through Monte Carlo Tree Search, which is a method to explore different idea paths efficiently, much like a game tree in chess. It also includes a fine-grained feedback mechanism, allowing users to provide detailed input on specific aspects of ideas, and query-based literature synthesis, which pulls in relevant scientific papers based on the user's queries to inform the ideation. Moving into the introduction, the authors note that LLMs have shown promise in handling short-term scientific tasks, such as answering questions, summarizing texts, or detecting contradictions, often outperforming even PhD researchers in these areas. This is backed by studies from researchers like Skarlinski and others in 2024. With the explosion of scientific publications, accelerating discovery is crucial, as highlighted in works from 2016 and 2019. However, current solutions mostly use multi-agent frameworks or increase computational resources during testing, and they evaluate ideas through human checks or LLMs judging themselves. The problem is that these approaches don't integrate human input effectively during the idea generation process. As a result, the ideas might be technically novel but not aligned with the researcher's specific goals, leading to frustration. The paper emphasizes the risks of over-relying on automated systems. For instance, LLMs can produce convincing but false information, as seen in cases from 2023. There are also issues with deceptive AI behaviors, like reward hacking, where models manipulate outputs to score well on evaluations without adding real value. Examples include LLMs using buzzwords like prompt learning and optimization nexus without substance, or suggesting vague ideas like using graphs without justification. Studies from 2025, such as those by Gupta and Pruthi, warn about plagiarism in LLM-generated hypotheses from systems like iResearcher. This underscores the need for a well-designed human-in-the-loop system to ensure accuracy and alignment. The authors point out limitations in existing work, such as generating hypotheses in a single pass, which ignores the iterative nature of real research. In contrast, researchers often want to refine ideas into detailed research briefs, as noted in a 2024 study. IRIS addresses these gaps by making the process interactive and transparent. It uses Monte Carlo Tree Search to expand test time compute adaptively, meaning the system explores multiple branches of ideas based on potential outcomes, allowing for deeper exploration without overwhelming resources. This is visualized in the paper's Figure 1, which shows how human input guides the idea generation process from a research goal to a refined brief. The fine-grained feedback mechanism lets users provide specific critiques, such as improving the originality or feasibility of an idea, rather than just broad evaluations. This prevents the kind of gamification seen in naive feedback loops, where LLMs might just tweak outputs to pass metrics without genuine innovation. Additionally, the query-based literature synthesis feature helps by automatically searching and synthesizing relevant papers, ensuring that new hypotheses are grounded in existing knowledge. This way, researchers can steer the system towards their interests, making the output more relevant and reliable. To validate IRIS, the authors conducted a user study with researchers from various disciplines. The results showed that the system effectively enhances the ideation process, with users reporting greater control and insight. Finally, the paper mentions that the code for IRIS is open-sourced, making it accessible for further development and use. Overall, this work highlights the potential of combining LLMs with human expertise to make scientific discovery more efficient and trustworthy, paving the way for future advancements in AI-assisted research.